Hello, everyone. My name is Paul Thomas, and I am going to be presenting the webinar Troubleshooting Rind Development in Washed-Rind Cheeses. I'm going to start by defining some of the cheese varieties that we are principally thinking of when we talk about washed-rind cheeses. We perhaps understand this broad family by the technique that's used to produce them. The basic principle being that the rinds will be washed, normally in a neutral brine solution during manufacture, to develop salt-tolerant bacteria and yeasts on the surface. The exact appearance that the cheese would take will be highly dependent on the physicochemical parameters of the cheese itself, and these will be derived from the manufacturing techniques that have been employed to make the cheeses. We have cheeses within this group which are predominantly mesophilic. We have versions which are predominantly thermophilic. We have some which are very soft, and we have some which are very hard. The exact appearance of the rind is dependent on these physicochemical characteristics. And this first example that I picked out here, which is longer, a French washed-rind cheese, very much in the lactic direction, made using mesophilic starter cultures, very long, slow coagulation periods, giving us a cheese which is very high in moisture. The appearance that we see on the rind, I'll just bring up my pointer here, we have this kind of wrinkly brain-like effect that we see on the surface, and the core is more pristine white. A fairly typical lactic cheese characteristic. The wrinkles that we're seeing on the outside, we can attribute in part to the high moisture of the cheese, and that difference in pH between the core of the cheese and the outer paste. We have other lactic cheeses, such as Epoisses, a not dissimilar technology, long, slow coagulation periods, little or no cutting of the curd, long, slow drainage, giving us a cheese with a very high moisture. We can compare and contrast that perhaps with something in the firmer cheese category, things like Fontina, in which the curds will be cut and scalded to higher temperatures, so about 34 to 36 degrees. Here we can increase the moisture being lost from the curds. We end up with a cheese which is firmer. The young cheeses may sit just on the boundary between firm, semi-hard, and hard, as per the Codex Alimentarius Commission classification in their general standard for cheese. Aged versions will go into the extra hard category. The moisture levels that we're seeing, of course, for the more lactic styles, significantly higher. Firmer cheeses progressively have less and less moisture. And as a general rule, the finer we cut the curd and the higher we scald it, the lower the moisture in the finished cheese. One of the key things that we see in these cheese varieties, Gruyere here, another example of a harder type of cheese. In this case, I'm going to draw your attention now, as we'll come back and talk about it later, to the appearance of the rind. We see that it's developed this kind of lovely nutty brown color. This is achieved through some early stage washing, which is followed by later dry brushing of the rinds. So we've got the variety of cheeses going all the way through from the very wettest and stickiest through to cheeses which are aged for longer periods of time, and which that pink or orange rind appearance has started to take on a more distinctly brown and dry crust. It's perhaps important for us to acknowledge one of the misunderstandings which has perhaps been prevalent in the industry over many years. It's very common still to find cheesemakers talking about Brevibacterium linens or B linens growing on the surface of their washed-rind cheeses. Historically, it was always believed that B linens was the surface bacteria that was growing on these cheeses. But about 15 or 20 years ago, microbiologists began to understand that the rind microflora was significantly more complex than had perhaps first been assumed. What is often attributed to B linens is in fact a very complex mixture of a lot of salt-tolerant bacteria and quite a few yeasts as well. And these may well include some members of the Brevibacterium genus, Brevibacterium linens, or Brevibacterium aurantiacum. But it's also very likely to include things such as Arthrobacter. This is an organism which is very rarely added by cheesemakers to their rind washing solutions or to the milk itself, but which will tend to grow anyway on the surface of the cheeses. It's perhaps more common to find historically cheesemakers adding Brevibacterium as a rind ripening culture to their milk or to their wash solutions. There are a couple of cultures which will include Arthrobacter, PLA culture from Danisco, or ARN. This would be a very good way of adding Arthrobacter. Even when it's not added deliberately by the cheesemaker, this tends to be one of the organisms which rises to dominance. We would also expect to find some species of coagulase negative staphylococci. Staphylococcus, of course, we know very well in the coagulase positive form. Staphylococcus aureus would be one of the pathogens of concern that we want to control during cheese making. Coagulase negative staphylococci, though, have a very important role in the ripening, not just of cheeses and washed-rind cheeses in particular. We also encounter it in the manufacture of salami and charcuterie products. This organism may have an important role in terms of protecting rinds from undesirable mold growths or imparting characteristic flavors to the cheeses. Examples would be Staphylococcus icorum, which is sometimes added as a rind ripening culture. We find a wide variety of other organisms which are less likely to be added as ripening cultures, but will find their way into the rinds of cheeses anyway. Agrococcus, Carinobacterium, Microbacteria, in this case, Microbacterium gabonense. This was bacteria which was very first isolated from the rind of a washed rind cheese made in the Republic of Ireland. And the bacteria has taken its name from the very cheese from which it was first isolated. We also have other organisms such as Halomonas, which may be coming in from the salt that we use. The crucial thing is that where we enjoy success with washed-rind cheese making, we need to create right conditions for these organisms to grow and to thrive, and then to reach stationary phase. If we have imperfect ripening conditions, if we don't select for what are essentially quite salt-tolerant bacteria, if conditions are too dry, if there's too much air movement within the store, we're going to give these bugs a very hard time, and instead of growing, they'll tend to die out. This is where we tend to find the greatest number of problems with washed-rind cheeses. Drying is often reported as a significant issue. On the other hand, very wet rinds will tend to support unstable microbial growth, possibly even spoilage organisms. And this in itself can produce off flavors, discoloration of the rinds. So we'll be looking at some of the environmental factors within the ripening room, within our cheese washing regime, which can encourage these bacteria in an optimum way. And we'll also touch on some of the issues that we find in manufacture that can have an impact on the success of rind formation or the appearance of the final cheese. Acidification, for example, will have a role in the development of the outer paste of the cheese. Excessive acidification will tend to cause very chalky cores and excessive ripening on the outside, which can cause unstable rinds. Essentially, the focus of today, we need to understand what conditions are going to support the growth of the organisms that we want to see. How do we prevent the growth of organisms which might be less desirable? When talking about washed-rind cheeses, it's quite common for the word terroir to crop up into conversation. This idea that there are certain places that will specifically encourage the growth of the type of organisms that we want to see, and that these places would therefore, over the course of time, become centers for washed-rind cheesemaking, places which are distinctly associated with washed-rind cheese varieties. It's a nice romantic idea, but it's perhaps one that isn't borne out by the science. And here we can point to papers such as that published by Wolf and colleagues, a team led by Rachel Dutton at Harvard a few years ago, 2014, I believe, in which they reported that the rind type and the moisture of the cheese, rather than geography, were most correlated with the microbial diversity of rind communities. Essentially, we get to this idea that no matter where we go in the world, cheeses of a certain rind type and physicochemical composition will tend to create environmental conditions within that cheese which will support the growth of certain types of organisms. And those organisms, no matter where we are on the planet, will take advantage of that ecological niche. It begins perhaps to rip up this idea of terroir, this idea that we can only produce certain cheeses in certain places, that certain organisms are native to certain places. And it begins to give us the idea that actually there is no one right place for making washed-rind cheeses. The organisms that we want to encourage, we can encourage anywhere. It's about getting the conditions within the cheese and the ripening room right in order to facilitate their growth. This should perhaps give us some encouragement as washed-rind cheesemakers. It means that essentially, no matter where we are, we have the ability to produce washed-rind cheeses that can compete with any other made on the planet. But it perhaps draws our attention more closely to the fact that we need to get those initial physicochemical compositional parameters right in order for the rinds to develop correctly. I think this would be my first important message from today's lecture. If we have significant problems with rind development, one of the first places we need to be looking is actually back in cheesemaking, in looking at our production records, in monitoring things such as the speed of acidification in relation to the speed of drainage. This is one of the factors that I've perhaps touched on in certainly the last lecture that I gave on acidity monitoring, but in several others over the years. We have to be focused initially on the composition of the cheese. It's important for us to recognize as well that the bacteria that we're looking to encourage in washed-rind cheesemaking, they like, as most bacteria do, they like fairly neutral conditions. They will grow optimally as the pH starts to come back up towards neutral. Acidification defects, therefore, can cause significant problems to rind development. Where the acidity of the cheese is too well developed, the bacteria will struggle to grow. The pH we would raise through the ripening cheese, but we can get significant imbalances in cheese composition, excessive ripening at the outer part of the paste, and very chalky cores in the center. We must be focused on manufacturing parameters, which involves careful monitoring of pH all the way through manufacture. And crucially, we need to look at the steepest part of the pH curve, as that normally correlates with the drainage period in most of these cheese varieties. Very rapid acidification at this time will cause problems that we're never really going to be able to correct for during the ripening of cheese. We have to get it right first during cheese making. We'll have a little look now at some of the cultures that we might want to add to the milk or to a wash solution. And we'll talk a little bit about how these cultures might actually be added. There's a variety of different cultures available. We have some which contain Arthrobacter, such as Danisco's ARN. We have cultures which contain various species of Brevibacterium, sometimes referred to as B. linens, but this isn't always the exact species which happens to be present in the pack. SR3, for example, contains Brevibacterium aurantiacum. It's still very common to find cheesemakers talking about them adding B. linens, though this name has become so inextricably associated with washed-rind microflora. We find cultures such as MVA, which contains Staphylococcus xylosis. We might find cheesemakers using a mixture of cultures to provide a wider variety, more diverse variety of starter organisms, rind starter organisms to their cheeses. Isn't always necessary to add these organisms. As I've mentioned before, the rind microflora is a completely diverse and often quite wild environment, which grows organisms which have salt tolerance and have the ability to take the ecological niche that we find on the rind of the cheese and to survive there. However, if we're having problems with rind development for a variety of reasons, it may be necessary to look at adding some of these ripening cultures to act as pathfinder organisms as much as anything, to pave the way for other organisms that will grow at a later stage. It would be incorrect to think that by adding these organisms, that is all that is going to grow on the surface of our cheeses, that somehow we have removed microbial complexity, that we're essentially making a product that is defined by the lab-grown cultures that are being applied to the surface. Romance here comes back into play, this idea that we can do things naturally or that we can take advantage of a commercial starter culture. But these are two separate worlds. It's quite a mistaken view, I'd say, even where we're using ripening cultures such as ARN or SR3. That's not the only organism which is going to grow on the surface of the cheese. Yes, it's going to be present in higher numbers. It may rise to dominance much sooner. But what we tend to find in rinds over the course of time, organisms which are not deliberately added by the cheesemaker will tend to grow and may even rise to dominance. And this has been reported by a number of authors in the scientific literature over the years. Sometimes ripening cultures can help, and the need to use these cultures shouldn't necessarily be seen as a bad thing. We will still tend to see microbial diversity, complexity on the rinds of the cheeses moving forward. Now, how would we add these cultures? Well, some, of course, will be added to the cheese-making milk. Some, however, may be suitable for including in a wash solution, a smear solution. This weak brine solution, which is applied to the rind of a washed-rind cheese to encourage these salt-tolerant bacteria and to neutralize the surface. The typical salt level that we find in a rind washing brine, well, it may be somewhere between about 1 and 5%, depending on the cheesemaker in question. The purpose of this brine solution is not to add salt to the rind specifically, not to add salt to the cheese. It's necessary for these cheeses to be salted separately, either by dry salting or by brining. The purpose of the rind washing brine is just to create the conditions on the rind necessary for these organisms. As I say, we can add some cultures to the milk. We can add some cultures to the smear solution. And here we find the product description for the ARN, Arthrobacter, containing ripening culture produced by Danisco. And down at the bottom of the page here, you'll see that the solution can be stored for a maximum of 16 hours at 5 degrees plus or minus 1 degree. So this is where the solution is made up in a 0.9% salt brine solution. We accept here, the manufacturers accept here, that there is a limitation on the length of time this culture can be left for. This has in the past posed some problems for some particularly small-scale cheesemakers who would make up a wash solution and perhaps aren't using their wash solution very often. And so it's sitting around for a long period of time. And then they begin to wonder why, after a length of time has passed, nothing really grows on the rinds of their cheeses. Essentially, the culture is losing viability over time. These organisms are rehydrated and suddenly discover that they're sitting at 5 degrees with very little to live on and with no conditions which are going to support their growth. So we're really not going to thank us for that. In this case, the cheesemaker might be better actually adding these cultures direct to the milk and washing with a brine solution rather than a brine solution that has been inoculated with the ripening bacteria. There is no one correct way that will work for all cheesemakers at all times. Some cheesemakers will opt to add to the milk and some will opt to add to the brine. But we do need to remember that where it is added to the brine, it will limit the shelf life of that inoculated brine solution. We would either need to make in much smaller quantities and replace these as necessary every 16 hours or so. We need to make up a fresh solution with fresh culture. Or we perhaps need to accept that adding to the milk may be a more viable option for us. Where we add to the milk rather than to the brine solution, generally the dose of the culture that goes in would be a little bit lower because, of course, there is greater potential for growth. If these bacteria are seeded into the milk, they will tend to grow in the milk and in the paste in the early parts of cheese making. The numbers may be a little bit higher by the time we get to ripening. If we are adding them straight into the wash solution, we might need to add a little bit more because the cheese, they've not been added previously to the cheese and they're going to have a slightly harder time in growing and rising to dominance. So 2 ways of applying these bacteria, no one right or wrong way, but we do need to accept that where these cultures are added into a smear solution, there is a limitation on their viability. Here we see some examples of rinds which have been washed and dry brushed, and we begin to see the development of this kind of nutty brown color. On this cheese here, which I believe is Deichkäse, which is made essentially a Gruyere-style cheese, but made in the very north of Germany, quite close to the Danish border. Some early stage rind washing will develop these pink-orange pigments, which we know are characteristic of washed-rind cheeses, and later dry brushing begins to develop this nutty brown coat. You see something similar here. I think this one was from a Bergkäse type cheese made in the south of Germany. We see some traces here where we've got the underlying smear, this orange, pinky orange color still coming through. And the outside of the paste has begun to dry and harden. We see some possible overgrowth with molds as well. And this creates a much more dry and stable rind. With hard cheeses, the hard and extra hard cheese categories within the washed rind family, very common to find this type of rind appearance. Why would that be? Well, it's very difficult to wash washed rind cheeses every day or every few days for a period of 6 months, a year, 2 years. Some of these cheeses age for a very long time. We can't just keep washing them and washing them and washing them to keep them sticky. We would end up with significant crystallization on the rinds, even unstable or damaged rinds. So the evolution of this rind type as perhaps something comes of necessity. In longer aged washed rind cheeses, it is very common to cease washing after a period of time and allow the rinds to become crusty. Here, on the other hand, we find some very young, in some cases quite pale and barely formed rinds. Here, these are cheeses that we make ourselves at my own dairy south of Germany. Here we still have this slightly yellow cheese color appearing through. The smear is just beginning to take, but it's a little bit patchy at the minute. Over the course of the following week or two, this rind will start to deepen in color and the smear will be more evenly taken up across the surface of the cheese. Some washed rind cheeses will be marketed when the rinds are very weakly developed, and other cheeses, as we've seen with the harder cheese varieties, will allow the rinds to develop fully, and then we'll dry them out and dry brush them for the duration of the ripening period. What I want to introduce you to now is this concept of the rinds approaching a stationary phase of microbial growth. We know that in cheese making, when we're encouraging the growth of lactic acid bacteria as starter cultures, we undergo these stages of microbial growth. We have a lag phase in which very little is happening. We have a log phase in which the microbes are growing and rising to dominance. We have this point in which they reach a stable, stationary phase and the level begins to plateau. And this would tend to correlate with the end of the acidification period. And we have a death phase, which would normally happen during ripening, where our starter cultures begin to die out. In doing so, they release enzymes which will impact the ripening of the cheese, flavor development, proteolysis. The rind microflora will also go through these various stages of microbial growth. We have a lag phase in which very little is happening. This will correlate with the very start of rind development. We have a log phase in which the bacteria will start to grow more quickly, possibly given more favorable conditions. We've been neutralizing the rind by washing it or adding some salt, which will select for specific types of bacteria. When they realize that there is a party to be had, they'll start having a party and they'll begin growing until they reach the limit of their growth potential, where they start to run out of resources, where they suffer from the effects of microbial competition, and then they begin to enter stationary phase. This idea that there is a point of stationary phase in which the rinds are reaching relative stability. Some of the organisms are beginning to die out. There is still some growth, but growth and death are kind of balancing each other out. This is perhaps a point in rind development that we want to aim for as cheesemakers. This is a point that we would tend to associate with increased rind stability. If the cheeses are still very young and wet, we tend to find the rinds can be quite sticky. So cheeses which have been inadequately washed, which are still in a logarithmic phase of growth, if we put those cheeses out too early, the rinds will tend to be a little bit unstable and they'll tend to be on the wetter side. If we can get the rinds to a stationary phase, then we might associate this with some limited drying of the rind, just enough to give the rind stability and make it less sticky. If we go too far past stationary phase, we might find that the rinds start to discolor. We might find an increased smell of ammonia, increased proteolysis. We might find some discoloration on the cheeses. This idea that there is an optimum point in which the rinds are dry enough, stable enough, and yet still young enough to avoid flavor defects. This is something which I have really tried to get on top of at my own dairy. And based on my experience working with washed-rind cheesemakers over the years, I would find a lot of people were washing their cheeses, getting them to the point of perfection, and then half the batch would be sold within a week or so, and the rest of the batch would sit around for another 2 weeks. And the cheeses that go out at the end of that period are significantly different to the ones that go out at the start. Essentially, the rinds begin to spoil, in some cases in a very short space of time. We see some discoloration on the rinds. We see the development of these ammonia and other off flavors. When I was developing our washed-rind cheese, I kind of took some inspiration from more industrial styles of cheese making. I'm an artisan cheesemaker, but I've worked a lot with larger scale dairies, and I think there's a lot of crossover, which is sometimes useful to look at. In particular, I wanted to stop the rinds from becoming too gritty. I wanted to avoid this crystal formation, which we'll talk about in just a minute or two's time. And one of the solutions that I came up with was to partially ripen the cheeses in barrier bags under vacuum pack. To leave them in these vacuum packs for a month or 2 months, and then to begin to cut out the cheeses as and when we were going to need them. So 2 weeks before I know I have a large order going out, we cut out some cheeses, we begin to wash them, and then we get the rinds to exactly the right state and pigmentation before they're packed and released. This tends to mean that we have a more steady flow of cheese going out of the ripening rooms. We'll only cut out and wash the cheeses that we actually need, and it allows us to get cheese out at this point of a stationary microbial growth in a fairly consistent way. So we have to think about the timeline of the formation and perhaps deterioration, if we leave it too long, of this the washed rind that develops on the surface of our cheeses. There is a point in which it is right, it has the correct flavor attributes, it has the correct textural characteristics. If the rind ages beyond that period of time, we find that some of these desirable characteristics may be lost, and perhaps less desirable characteristics, surface drying, surface molds, crystallization, discoloration, or unpleasant aroma, they would tend to become more prevalent. So we need to look at the timeline of cheese ripening as well when considering this approach to the stationary phase of microbial growth. If we begin washing too early, those rinds are going to peak very early, and we might start to find less desirable rind formation in the later stages. Worth considering the full timeline of these cheeses and ensuring that we don't start washing too early. For that, there are barrier bags that we can use to prevent rind formation until we're ready for it to happen. It gives us a little bit more control. Next, we see some rinds which are beginning to show the appearance of surface molds. Now, some washed-rind cheeses, this would be a desirable or at least an accepted characteristic. Here we can look to the Taleggio cheese of the north part of Italy. In that cheese, it's fairly common to find this orange exterior to the rind with some overgrowth, normally attributed to Penicillium expansum, a kind of bluish green wild type Penicillium, which tends to be fairly prevalent in the dairies, particularly those that are using wooden cases to ripen the cheeses. In some cases, this mold appearance will be accepted. In others, it is potentially undesirable. We see here on the surface of these cheeses, we have some mold overgrowth, some little black spots forming. In this case, they tend to be associated with small pits in the surface of the cheese. And in this slide, we see that essentially the rind has begun to develop and overgrow those molds, but it leaves these rather ugly dark patches just underneath the surface. If we want to prevent molds from forming on the surface of the cheese, then we need to get in early and develop the washed rind very quickly. We need to allow for sufficient yeast to be present to outcompete the molds. We need to start our washing regime quite early, and where necessary, repeat that with every day, if necessary, every other day, if not. With many washed-rind cheeses, we might find that we're washing somewhere between every day and every 3-4 days. The more we wash, the more we neutralize the rind, the faster we allow the implantation of these rind bacteria. The less we wash, the more air movement and the colder the conditions within the storeroom, the more likely we are to hand a selective advantage to some of the molds rather than the yeasts. In particular, temperatures that are below 10 degrees will very definitely facilitate mold development and tend to exclude the yeasts and the rind ripening bacteria that we're looking to encourage. These bacteria would be happier at temperatures above 12 degrees and ideally closer to 14 degrees. The yeasts certainly will not grow significantly below 10 degrees. So cold temperatures are one of the first things that we would need to consider when trying to work out if there's an issue with ripening conditions impacting the growth of molds on the surface. Beyond that, we would need to look environmentally because certain molds will become prevalent in either the make room or the ripening room. We need to look at niches within those rooms which might be allowing for microbial growth. We need to look at cleaning and disinfection regimes. Possibly need to look at some kind of sterilization, such as ultraviolet or ozoning, where molds are associated with some form of environmental contamination. We need to eradicate them from the space. But we have to accept as well that molds are very ubiquitous organisms. They're very widespread, And if they're growing significantly on the surface of the cheese, having ruled out environmental contamination as a significant issue, we have to look to the temperature and the wash regime to see whether we're allowing these organisms a foothold that they shouldn't be getting. Dry rinds and cracking can also be a significant problem, and here we can attribute this specifically to ripening room conditions. This perhaps is one of the more common issues that I find reported by, particularly by cheesemakers who are new to washed-rind cheese making or who are making very small volumes of cheese. The humidity in the store needs to be at around about 90% or above, 95%. If the humidity is significantly below this, we'll tend to find significant problems with splitting of the rinds, cracking. In this case, we see some mold beginning to grow down into that crack. It'll take advantage of this little niche that's opened up for it. And we see this kind of crusty, scaly rind appearance here starting to dry and crumble off the face of the cheese. This would instantly take us to looking at humidity in the storeroom. We need to increase the humidity. We can put a humidifier in, we can put some water down on the floor. We would also need to look at the temperature of ripening because, of course, the colder the air, the less its moisture holding capacity. It's easier to hold humidity where the temperature of the room is at a fairly stable 14 degrees than it would be where the temperature drops down as low as 8 degrees before the cooling switches off. So it's important for us to look not just at the humidity levels, but also the thermal cycle within the room. An associated issue, we would sometimes find the cheeses that are matured near the base of the room drying more significantly than those near the top of the room. This would tend to reflect the fact that cold air sinks towards the bottom. Cold air has a lower moisture holding potential and has greater potential to dry out the cheeses. In these cases, we see less cracking and splitting on the surface, and the cheeses above them may look quite happy by comparison. But we do see that the rind microflora has completely changed. In this case, it's become quite dry, white, powdery, possibly the growth of some of the mold like Geotrichum being used as one of the ripening cultures. But a selective advantage has been given to that rather than the sticky orange bacteria, yeast rinds, which we're looking to encourage instead. So we need to think within our cheese room, not just about total conditions within that space, but also point differences between the low part of the room and the high part of the room, between parts of the room that are closer to the cooling system, parts which are further away. Air movement within that store can impact the drying and the outcome that we see on the surface of the rind. In the next slide, we see two associated issues. We see a discoloration defect, but we also see an acidification defect. In this case, the cheese is intended to be very much in the kind of Gouda family of cheeses, but we find at the paste this slightly chalky, crumbly core, which doesn't break down quite as easily as it should, whereas on the outside we find more significant breakdown. This dark band appearing just around the outside, this section just underneath it, which is becoming almost liquid, and this discoloration that we're finding in the very corners. What has caused this problem? Well, it's the acidification defect itself, which sets up the conditions whereby the outer paste will begin to over-ripen and the inner paste will stay very chalky. We find this phenomenon in a wide variety of different cheeses. We see it in bries and camemberts just as much as we see it in washed-rind cheeses. The pH that we find at the rind will rise very rapidly. pH at the core will stay very low, and so we see this divergence between the rind and core pH. In this case, it has gone so far as to cause discoloration in the outer paste. Essentially, the outer part of the cheese is over-ripening, gone through stationary phase, it's now starting to spoil, and we see this discoloration defect as a result. This is not an issue that we can really resolve through rind washing and ripening techniques. It would have to be something that we would address through cheese manufacture itself. So I go back to that starting point, that the composition of the cheese is fundamental to avoiding issues with washed rind development. I once saw this particular phenomenon taken to an extreme, and I think the paste of the cheese was somewhere in the region of about 4 or 5. The outer paste of the cheese had gone beyond neutral and was heading up towards pH 8. The cheese was completely unstable, and the rind did not smell at all pleasant. We have to look to composition to correct some of the issues that we find in rind development at a later stage. The next slide is something of an oddity, which was reported by a team, I think, led by Ben Wolfe, a name that we remember from one of the earlier studies, who identified that some indigo and indirubin-producing strains of Proteus and Psychobacter, Enterobacteriaceae, are associated with a purple rind defect in surface-ripened washed-rind cheese. Here, of course, we see that the rinds have developed this kind of reddy purple color. Enteros are an organism that we would tend to find occasionally in washed rind cheeses. Enterobacteriaceae often used as a hygiene indicator. The wet, neutral conditions of a washed rind cheese will allow the growth of some enteros if they manage to get in there. Proteus would be one of the spoilage organisms that we would perhaps quite commonly associate with washed rind cheeses, causing a very distinct and unpleasant, dirty aroma to the rind. In this case, the organisms have also produced some significant pigmentation growing across the surface of the cheese. This is perhaps a little bit of an oddity. I don't think I've really seen this phenomenon with my own eyes. Had it reported to me by a couple of people, but it doesn't seem to happen that often. These enteros acting as spoilage organisms, the smell of Proteus on the surface of a cheese, this is something which is quite common there. For spoilage, we would perhaps need to look at the composition of the rind. If we're picking up high levels of entero, this is in itself associated with some undesirable rind characteristics. In the next slide, we see a picture of some rinds. Here we're pitted with some surface molds, little spots just here and there. In this case, it's associated with the cheese being a little bit too firm at the point that it's molded up, or to whey trapped in the molds at around the time of drainage. How can we prevent this? Well, once again, we need to look back to physicochemical characteristics to cheese making process. If the cheese is too firm, we need to delay moisture loss from the curds. If it's a drainage problem, we need to look at putting drainage mat or cheesecloth down to encourage a more stable rind appearance. This is one problem, though, that we perhaps can deal with through rind washing regime. Some gentle scrubbing of the rind surface when we're applying the first wash will slightly abrade that surface, but it can help to seal up small holes that appear in the surface of the cheese, such as this. If we are quick in sealing them, the molds will not grow in those holes. Crystal formation is something which has been reported by quite a lot of washed-rind cheesemakers. Here we see a paper published by Tansman and colleagues in which they reported a range of different crystals being formed during the life of a washed-rind cheese. Compounds such as brushite, calcite, ichite, and struvite were identified. These are variously calcium hydrogen phosphate, two forms of calcium carbonate, and magnesium ammonium phosphate. The authors reported that there was a distinct staging to the formation of these particular crystals, brushite forming earlier, calcite tending to come in slightly later, followed by ichite, and then struvite finally, as the rinds were more well developed. I've had over the years some cheesemakers who want to avoid this crystal formation because it tends to cause a gritty or sandy texture in the cheeses. Well, how do we do that? One of the things we need to do, perhaps to look at the findings of this paper, they report the increase in the crystal level over the course of time, significantly at the rind, as we see here. Seems to follow that that basic pattern of lag phase, log phase, stationary phase. Well, that's certainly what's happening here. The crystals will begin to form. The formation of the crystal will catalyze the formation of further crystals. They will act as a condensation nucleus, which will allow more crystals to form. So as soon as they start forming, they begin to form much faster. So not maturing the rinds for too long, the technique that we have employed ourselves in putting cheeses into barrier bags and only cutting them out as and when we're going to start needing them. This is one thing which can help to limit the formation of these crystals on the surface if they are undesirable. We also tend to find that crystal formation will increase significantly where we've got very wet cheeses to begin with that then undergo a period of drying. This drying will tend to promote crystal formation. Cheeses which are washed with a lot of wash solution on the cloth or brush in the early stages, they will tend to be more prone to crystal formation at a later stage. And those cheeses which tend to be brushed or washed with a less wash solution on the cloth, they will tend to be less prone to crystal formation. Okay, so young old smearing is a technique which involves the transfer of the rind microflora from very old cheeses to very young cheeses. This is sometimes it's something that's carried out a lot with things like Bergkäse, Gruyere type cheeses, where we have a smear solution which is positively contaminated with rind microflora from older cheeses and is then transferred onto young cheeses. There's a lot of artisan Bergkäse producers in the south of Germany who will use the same smear solution that is applied to absolutely everything. It's a very good way of getting our rind microflora to develop quickly, but it is also a very good way of transporting pathogens, particularly Listeria, from one batch to another. The risk of cross-contamination is increased. The young old smearing technique, though, because it does help with the implantation of the smear, it may have a role in creating protective effects of the rind, as we'll see in, I think, one of the next slides. Rinds that very quickly approach a stationary phase are perhaps associated with slightly lower risk of Listeria growing, spreading from batch to batch. This technique is risky. It can have some positive benefits, but it is risky. It is perhaps a technique which is better suited to harder cheeses, which are less likely to support the growth of Listeria. It does allow for a monitoring point, as in the smear solution is sometimes recommended as something we can test for presence of Listeria. If we're picking up Listeria in the smear solution, of course, we've got Listeria in one or more batches of cheese. We would have to assume that anything that had been in contact with that smear solution would be potentially contaminated. So I present this as a technique which is sometimes employed, but which, where it is employed, it must be carried out carefully. And it does tend to remove this idea that there are individual batches. Essentially, everything produced by the dairy becomes one batch. If we have a microbiological problem in one cheese, it is present in all cheeses. The growth of Listeria has been studied by several authors, including Carminati and colleagues. Here they use Listeria innocua, a non-pathogenic form of Listeria, as a way to understand how Listeria monocytogenes might spread around a Taleggio dairy, one of the washed-rind cheeses from the north of Italy. And they reported that Listeria contamination and the extent to which it could grow and dominate the ripening room was highly dependent on the time the contamination occurred. If contamination occurs very early before the rinds are developed, the Listeria spreads everywhere, and it does so very quickly. Listeria was less able to colonize the surface of the cheese and to spread from batch to batch, where contamination came in once the rinds had achieved stationary phase. This begins to develop the idea that when the rind is imperfectly formed, the cheeses are perhaps more prone to contamination at that point, not just with molds that we've talked about earlier, but also potentially pathogenic bacteria such as Listeria. Where Listeria does form, of course, it's more common to find it on the rind rather than in the center. If it's associated with contamination during ripening and subsequent spread, of course, it's going to be higher in the center. Listeria is a significant hazard which needs to be considered by the washed-rind cheesemaker. There has been a recent incident in the UK which was associated with a washed-rind cheese. Historically, if we look back over many years, this type of cheese category crops up significantly in terms of Listeria risk. It's one of the highest risk categories that we can have for Listeria growth. So everything has to be done in a very careful way. We need very high standards of cleaning, disinfection, prerequisite controls over the hygiene of manufacture and ripening, and a microbiological sampling plan that would allow us to pick up levels of contamination or to evaluate environmental contamination within the ripening environment. It can be very hard to find Listeria if it's present in product. If we have an emerging problem in terms of environmental contamination, though, some environmental swabbing for Listeria is strongly recommended for these cheese types. There are, of course, products which we can use, bacteriophage-based products specific to Listeria, such as Listex P100, which are marketed specifically for their ability to control Listeria on the surface of foods or environmentally. These have some limited effect, perhaps. Perhaps we don't have 100% effectiveness from products such as this. In particular, the European Food Safety Authority identified that there was the potential for Listex-resistant strains of Listeria to rise to dominance. So the use of these products may be used as part of a belt and braces approach to Listeria control, but fundamentally, we have to go back to basic prerequisite controls to prevent contamination of the workspace, of the ripening room, and from there, of the product. So we have time for a few questions, I think. I just bring up the chat. And I'm going to stop sharing while we go through the questions. So, can large deep splits in a cheese be a reflection of the cheese make process as well as the environment that's just too humid? If we have points of weakness within a cheese, they will tend to split. So let's imagine for a second 2 lots of curd which have are fairly dry and haven't quite fused together. As the cheese ripens, as it loses moisture, they will tend to tear open. Cheeses which are too firm to begin with, they perhaps might struggle to press together. If we have bits of curd that are cold that are put on top of one another, this will create a point of weakness. So yeah, I'd say there are definitely conditions within cheese making that will allow splits to occur. One other thing, though, that I've sometimes seen with, not necessarily with washed-rind cheeses, but with some harder cheese varieties in the kind of Gouda category, where curds end up in the cheese that are particularly wet, as in we've not got enough moisture out of that cheese, or we've ended up with some bits of curd that aren't cut as fine as they should, or that haven't been stirred as much as they should. We might associate these very soft curds with some rind instability where they happen to be present on the rind of the cheese. As I say, in some Gouda type cheeses, we end up with this little patch of very soft curd. If you press it, once the cheese comes out of the mold, you end up with a little spring of whey coming out of it because it is that wet. As the cheese dries, that will just turn into a great big hole, and we'll start to see molds growing down into that hole. So yeah, I think we always need to go back to cheese making process as a potential cause for physicochemical conditions within the cheese that might facilitate splitting and contraction of the curd around that split as the cheese is drying. When I use barrier bags to retard development of the surface, do I vacuum pack as well? Yes, and that limits the development of the molds. It's important to recognize, though, when we are vacuum packing cheeses, we have to consider whether there is a risk of the growth of non-proteolytic Clostridium botulinum, and this typically wouldn't grow where the level of aqueous salt in the food is 3.5% or above, or where the water activity of that food is less than 0.97. So the use of vacuum might cause us to review whether this anaerobic organism was a potential hazard to consumer health. If the physicochemical parameters of the cheese, though, allow for it to be vacuum packed, we find no issue with doing that. The cheese partially ripens in the vacuum bag, and we actually find that when they're cut out, the rinds take up the wash solution and begin to produce pigmentation after very few washes. After a single wash, we normally see some very subtle pigmentation to the rind. After 2 washes, we have a washed-rind cheese. So in allowing the cheese to partially ripen, we seem to be doing ourselves a favor and making our lives easier later on. It not only allows us to produce stable rinds, it allows us to produce them much more quickly.
So, Paul, we have gone a little bit over time, but there is one more question that has just come in from Terrigo Cheese.
Okay. What's the role of micrococci on geotrichum? Oh, hang on. Lost in a second.
It says, what is the role of micrococci and geotrichum in soft surface cheese, and how does it work?
So geotrichum is a yeast. It's a yeast which lives right at the kind of evolutionary boundary between the yeasts and molds. But the essential role of geotrichum is that it neutralizes the rind pH. And in doing so, we'll set up conditions that will allow the rind ripening bacteria to grow more optimally. Geotrichum in very soft cheeses, such as Langres, in association with other yeasts, such as Debaryomyces, which is a more salt-tolerant yeast, these organisms will produce that wrinkly brain-like effect that we see on the surface of the cheese. It's very common for cheesemakers to talk about that being due to geotrichum, but it's due to geotrichum plus another yeast. And we find that the wrinkles that we would get where geotrichum grows alongside Debaryomyces are subtly different to those that we might expect to see when grown alongside Euroia, which produces that very kind of brain-like appearance on the surface of the cheese. So they are essentially there for flavor development, partial proteolysis for cheese paste, and rind neutralization. Micrococci, they are there because they have an impact on proteolysis and flavor development, but there is some evidence that they will also limit the formation of surface molds and unwanted contaminants on the outside of the cheese. They can have quite a strong flavor, so they certainly impact flavor development, and the dose tends to be relatively low in comparison to some other ripening cultures that we might be using. In many cases, a little goes a long way. But the role of micrococci, essentially flavor development and this kind of bioprotective effect. That in itself can be hard to quantify. Just because we're using micrococci doesn't mean that mold problems will go away of their own accord. Once again, we need to look back to environmental controls. Are there molds present within the ripening room that we need to be controlling? And physicochemical parameters in the cheese that might be allowing these organisms to have a niche.
Okay.
Okay.
Go on. Wendy has said for another topic she'd like to better understand the reasons.
And I think that might make an interesting webinar. It would depend very much on the cheese variety in question. So there's things such as cheddar type cheeses where the curds are pressed together once acidified and salted, where they are much more prone to splitting because of that that point of weakness between the two parts of the curd.
Very good. Yeah, we have run webinars on the topic before, and but it wouldn't hurt to revisit it again. So we'll see how we go there, Wendy. All right. So Paul, thank you very, very much.
Thank you, everyone.
And you speak in such a relaxed manner. It's a delight to listen to you, and we really appreciate all the effort you put in.
Is that a polite way of saying that I put everyone to bed?
No.